Bridge technical condition evaluation calculation includes elements, components, section, full bridge score calculation, calculation method details. Article 4 of the Highway Bridge Technical Condition Evaluation Standard. This section mainly explains elements, component score calculation, after on-site inspection, record defects of each component, including defect types, defect locations, defect description. Compare with the Highway Bridge Technical Condition Evaluation Standard. Items 5 to 10 determine the defect scale. The component score can then be calculated. Component calculation refers to Formula 4.1.1. In the formula, PMCI, BMCI, DMCI respectively represent the superstructure, component scores of superstructure and substructure and bridge deck system. DP represents the deduction value of a certain defect in a component. U represents the conversion value of a certain defect deduction. The subscript X represents the defect ranking of the component. Component score equals 100 conversion value of all defect deductions for the component. Next, I will explain the calculation methods for defect deduction values and conversion values. First, query of disease deduction values. The DP disease deduction value is scaled based on on-site defect detection, and the highest scale of this defect in the standard, obtained by referring to Table 4.1.1. For example, when one defect, crack, appears in the upper component, on-site detection scale is Class 2. Refer to Table 5.1.1 to 11. The maximum crack scale in the standard is Class 5. Refer to Table 4.1.1. Crack deduction value DP equals 35. A component may have no defects, may also have one or more defects. The deduction values for all defects of a component can be queried based on inspection results. Second, disease conversion value and component score calculation. To avoid the final component score being 0 or even less than 0, when a component has multiple defects, defect deduction values need to be converted into U, called disease conversion value. First, when no defects appear in components, all disease conversion values of components equals 0. The component score is 100 points. Second, when a component has one defect, crack deduction value DP1 equals 35 points. When there is only one type of defect, conversion value equals deduction value of 35 points. The component score equals 100. Crack conversion value equals 65 points. Third, when a component has three defects, respectively, cracks, pitted surface, void, on-site detection scales are Class 2. Class 2. Class 2. The maximum scale for these three defect types in the standard is Class 5. Class 3. 4 categories. Refer to Table 4.1.1. The deduction values obtained are 35 points, 20 points, 25 points. Then sort disease deduction values in descending order. DP1 equals 35 points. DP2 equals 25 points. DP3 equals 20 points. Conversion value U1 equals 35 points. U2 equals 11.5 points. U3 equals 6.2 points. component score equals 100 minus U1 to U2 minus U3 equals 47.3 points. The above explains component score calculation. First, after calculating the component scores, then the part score can be calculated. Part score calculation details can be found in Formula 4.1. 2. Component score equals average score of all components in the part. 100 points, the minimum score of all components in the part /T. The T value is obtained by querying table 4.1.2 based on the number of components in the part. The table ultimately has corresponding T values based on the number of components. For example, the substructure of a certain bridge is a light abutment wing wall as a component. The wing wall components of this bridge include for wing wall components. The 4 component scores are 35 points, 60 points, 75 points, 100 points. The number of components n is 4. Refer to table 4.1.2. T equals 9.5 calculated according to Formula 4.1.2. The wing wall part score is obtained as 60.7 points. Second, when the component score of a main component is between 0 and 40 points, rating values of main components no longer calculated according to Formula 4.1.2. The score of this main component directly takes the minimum component rating value. For main components of different bridge types, refer to Highway Bridge Technical Condition Evaluation, Standard Table 3.2.2. For example, main load-bearing structural components in the superstructure of a certain bridge. There are a total of 10 box girder components. Among them, one box girder component equals 38 points. Below 40 points, refer to Table 3.2.2. The box girder belongs to the superstructure's load-bearing components. It belongs to main components. Apply this standard. Take the minimum score of 38 points from 10 components. A score of main load-bearing structural components. In the end, I will summarize this lesson. First, based on the component defect scale, query the defect deduction value of components. Calculate disease conversion value. Finally, calculate the component score. Second, based on the number of components and component scores within the part, calculate the part score. Also pay attention to the main components. When a component score is in the range 0-40, the score of this main component directly takes the minimum component rating value. Through the learning in this lesson, it is hoped that you must master theoretical knowledge during learning. Basic knowledge such as operational rules and calculation formulas. Have a clear understanding and thorough comprehension. Continuously consolidate and improve, and apply them flexibly. Okay, that's all for this lesson. Goodbye. After class, please consider the following questions. When a component has multiple defects, can the component score equal 0 points?